Hello everyone and welcome back to the Chapter 7 Introduction to Python on lists and tuples. Now last video we went over how to do create lists, how to manipulate lists, how to splice lists, and so on. So now what we're going to move on to is some more different methods we can use to actually manage lists. So the first ones we're going to look at is just some useful list methods we can actually use when working with lists in Python. Specifically, we're going to be looking at things like the append method, which allows us to add an item to the end of a list. We're going to look at the index method, which allows us to return the index of the first element whose value is equal to that item. Again, with this one though, be careful because if you use it and that item does not exist, a value error exception is raised. Next, we'll also be looking at the insert method, which allows us to insert an item into the list at a specified index. And when we do this, it expands the existing list and everything is shifted to make room. So think about just like putting a book on a bookshelf and shifting books around. We also have our sort method, which just sorts them from in ascending order from lowest to highest. We have a remove, which allows us to remove the first instance of an item from a list. Again, just like with the index one, if it is not found, a value error is exception is raised. Then we have our reverse method, which we can use in conjunction with the sort method to reverse sort or just reverse the list in general. Then we have our delete, which we remove an item from a given index. And then we have our min list and max list methods as well. So all of these are going to be very useful when you're working with lists in Python. So the first one we're going to look at is the append method. So here you can see we have a list of users. So we have users with Ben, Megan, Jim, and Jean. Then we can say, hey, does that user exist in this list? If it is, we just say user found. Otherwise, we can say users.append and then the name that we want. What this will do is if you're ever building some kind of like server or website and you're trying to see if a user already exists, if they're trying to sign up, this is a really useful thing if you're making a list like that. But it's the same kind of concept. So if you're ever making like a raffle and you're using a list to keep track of all the names, then you may not want to have the same person in twice. So append, and you can check first to see if it's in the list. If it's not, you can append. The next one we have is the index method. In this case, we have our checking favorite food. So what we can say is we have our favorite foods. So we have nachos, salmon, chicken, steak, and churros. We can then say, we can say try, because remember, if we use our index and it doesn't exist, then we're going to have an exception. So we can say try, and we say fave is equal to fave foods dot index, and we ask the user here with the input function which food to check. So if they enter a food that already exists up here, it won't have an issue, and they'll say that is your blah favorite food. So for instance, if we were to do this and take this code over to the actual terminal, the actual PyCharm here, we can say fave foods equals, and let's just put something here. So we'll do steak, chicken, we'll do salmon, something like this. We then say try, and we'll say fave equals fave foods dot index. We want the index, we'll do input, so we'll do int input, so we need a number, and we'll say what is your favorite food? Just like that. Okay. And if we do that, we'll do an exception here. So we'll do except, like that. And it'll print that is not one of your favorites. And then if we do get one back, we can print that is your blah favorite food. Pick out format and we'll put fave. All right, so if we run this, we'll say what are our favorite foods. If we put in something like burgers, they'll say that's not one of your favorites because it's not in the list. But if we put it in, let's say steak, they'll say, ooh. So right here we have what is your favorite food? And we put in, so if I break this down a little bit, we can do index or food equals input. No, sorry. We don't need an int there actually. All right, so we'll do just like that. And we'll run this again and we'll say steak. And I'll say that is your 0 favorite food. Noting here that the index for steak is 0. So say that is your 0th favorite food. If you want to make this look nicer, we can do +1, just like we do normally. We can say steak and, oops, sorry, steak. And it'll say that is your one favorite food or your first favorite food. Now you can break this down more and you can have different if statements saying if the number is 1, you can say that is your first favorite food, and so on and so on. But this just shows you right here that you can use the index to find the location of that in the actual list. All right, moving on, we also have the insert method. So let's say we have our favorite foods here like that before, and we want to add a food, and we want to rank it as well. So let's say number 1 is nachos, 2 salmon, 3 chicken, 4 steak, 5 churros. If we want to insert a food, we can ask for the input, what is your food to add? We can then take that and get the rank that they want, make that an int here. And then we can say favfoods.insert at that index, that food. So if we come back over here, we have our favorite foods. We can say we want to do favfoods.insert. Let's say we want to insert it at index 0, so our new favorite food, and we'll put nachos, just like that. We then print favfoods. It'll now say nachos, then steak, chicken, salmon. So everything is shifted over 1. Every index here, the 0, 1, and 2, are all offset 1, and the new one is put at the front. We can make a least favorite food if we wanted to by doing favfoods.append, like we talked about earlier. And let's say we'll do broccoli. I don't know if that's how you spell it, but we'll just work with it from there. So if I run that now, broccoli is the least favorite, nachos the most favorite, and you can append to the end, because append always goes to the end, and insert we can put anywhere we want in that list. If you want to put it at the beginning, you do insert 0, comma, what you want to insert. So moving on, we can now go to the sort function here. So now in this case, if you notice here, the sort method allows us to sort this. So over here we have different users, Ben, Megan, Jim, and Jean. If we sort it, then print users, we print a sorted list. So here, if we wanted to sort this, we could print favfoods, but before we print it, we can do favfoods.sort, just like that. And if we run that now, we now have broccoli, chicken, nachos, salmon, and steak. Remember that with strings, when we sort them, because remember, sort does numeric, we're not sorting them based off of their actual like characters here. We're sorting them based off of their Unicode. So that puts them in alphabetical order. So with sort, we can sort different lists. I know that breaks the ranking of the favorite foods, but we can still do it if we wanted to. Moving on, we can then do the remove function here. So if we wanted to remove something from that list, we could also do sort, and then we take that actually, and we'll do remove. And if we remove something, we'll need to make sure we put in a try except, just in case that doesn't exist. We'll do try, we'll do accept, and we'll say print that food is not listed. If we remove, we can do an input here saying what food to remove, like that. We run that now. And let's say we want to remove, steak. So now you see we don't have steak there. So now we take the actual string you wanted to remove, the item from the list you wanted to remove, and we remove it using .remove. We run that again though, and we put in something like churros. That food is not listed, so the list has not changed. Okay. So after remove, we also have reverse. So just like before, we can do sort reverse. So if I wanted to do this again, we could do favfoods.sort. And then you can do favfoods.reverse. Reverse. Like that. And now you'll see, if I do this, I'll just put this in here like that. Now we have steak, salmon, nachos, chicken, broccoli. So it's reverse ordered. You can also do sort, and then you can do reverse equals true, like that. And if you run that again, it'll give you the same thing. So technically speaking, you can put them in the same line, but if you want to do them separately, you can do that as well. Okay, so we have a reverse function as well. We also have our delete function here. So instead of saying remove specific food, we can also, after sorting it or before sorting it here, so let's keep it in the right order. If we run that now, we don't remove anything. We have nacho, steak, chicken, salmon, broccoli. If I just want to remove, if I want to delete, I can do del, favfoods, and let's do our second favorite food. If I print that now, it says nacho, steak, salmon, broccoli. It removes chicken because remember we put nachos in first, so that's 0, 1, 2, so it removes chicken. We have salmon, broccoli. Okay, so you can still delete stuff out as well. Then we also have our min and max. So here you can see we have our grades. If you do min of a list, just like this, it'll actually go through and give you the minimum value. So in this case, it'll give you 73. If you do max of a list, it'll do the exact opposite, and it'll give you 97 in this case. All right, so let's go ahead and see what you got, how you guys are faring so far. So if I were to ask the question, what is the difference between the remove method and the del statement, you could say that the remove method removes first occurrences of items, and the del removes indexes at items, or index, removes items at index. So what the difference is that for remove, I give it a specific value or item that I want it to remove. It doesn't matter where in the list it comes from, I just want it to remove that one item. The del in this case, I could have multiple items of that, but I don't really care what the item is, I just want to remove it at that index. So if I ask you to describe the following methods, you could say that the index method returns the index of the first occurrence of a given item. Insert inserts a given item at a specific index in the list. Sort sorts the given list. Reverse reverses the given list. Now let's look at this. Assume the following statement appears in a program. We have names equals an empty list. Which of the following would you use to add Wendy to the list? Would you say names sub 0 equals Wendy, or names.append Wendy? Now remember what we talked about before. If this is an empty list or that index does not exist, you cannot change that. This is an update. This is a setting command. This is an adding command here, or statement. So since the index at 0 doesn't actually exist, you can't use the first, like we talked about before. So instead, if you want to add something to a list, to an index that does not actually exist, you need to use the append function instead. All right, so let's try this problem here together. Let's write a program that asks the user to enter a series of 20 numbers. The program should store the numbers in a list, then display the following data. It should display the lowest number in the list, the highest number in the list, the total of the numbers in the list, the average of the numbers in the list. All right, so let's go over here, and we're looking at 7-4. So go to that problem, and we'll start just like before. So we'll do def main, and then we'll say if underscore underscore name underscore equal equals quote underscore main underscore colon. Do main just like that. So now we have our Python file set up correctly. So what we need to do is we need to get 20 numbers, and we need to write them into a list. So what we'll do is we'll have numbers equals an empty list, and then we'll say for I in range of 20, because we want to do this 20 times, we'll say try. We'll hold off on the try for a second. We'll bring that in a second. Let's just do this. Let's get numbers dot append input int of input. So we're getting the input from the user. We'll say enter a number. Now, the reason I was saying we needed the try is because we're going to need to put all of this into an input validation loop. So we'll do while true, try this right here. If they do not enter a number, like a string or something like that, we'll do except, and we'll print that is not a valid number. If it is true, we'll go ahead and break. So every time we go through this, we'll go in this loop, we'll try to get this number. If it's wrong, it'll bring this back, and we'll come back around every time until we get a right number, which means that this statement won't break, and then we'll break out of this loop, and then we'll come back around again for 20 times. All right, so if we print numbers after that, just like that, and if I run this program real quick, we'll say 1, let's put a whole bunch of 1s in. Let's keep going. Okay, so now we have 20 numbers. So if we go through this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 numbers here now. All right, so we can obviously make this look nicer if we wanted to. We can say enter the blah number, and we could do dot format with I right here. So it just looks so they can see that they're not going crazy. So if we run that now, you can see we can say enter the 0 number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down. So then we have 19, and that's all full 20 because we started 0. All right, so now that we have our numbers, we can now go through and store the numbers in the list and display the following: lowest, highest, total, and average. So what we can do is we can come in here, we can say print the lowest number is something. We'll do dot format. And here we're going to do numbers dot min. Just like that. Or should I say min of numbers? So we're going to basically be using this guy right here. So we're going to do min of numbers. We're going to do min of numbers, just like that. And then we're going to do like this. We'll say the highest number is the max of numbers. So if I run that, and let's put in some numbers, let's put in like 1,000 or 10,234, and then we'll put negative 56, and then we'll put a whole bunch of like ones in the middle. Okay, so it says the lowest number is negative 56, and the highest number is 10,234. So that gives us that. Now, if we wanted to actually go about summing the actual numbers in the list, we have other options as well. All right, so if we want to sum the numbers, we can do the same thing like we did min and max. Now, I know we haven't talked about it, but we can do the total of all numbers is format sum of numbers, just like that. And then we can do the average as well. We can say the average of all numbers is this, which we do dot format again. We'll do sum of numbers, and then we'll divide that by the len of numbers, just like that. So basically, by using all of these input in these internal functions, we don't have to do any kind of loops, for loops, or anything like that. And what we can do instead is we run this now, put in 10,234, negative 500, put a whole bunch of 2s and 1s and 3s and whatever else in here in the middle. Again, you see if I don't enter it correctly, it's fine. Okay, so this is the minimum, which we see up here. This is the maximum. The total, if we add them all up, is this, and the average is this. Okay. So as you can see, we have plenty of useful built-in functions: min, max, sums, lengths. We have our actual list functions like methods like append and such like that we can all use to actually get different attributes of the list without having to actually do a lot of work on it. All right, so with that being said, I want you guys to try this. So on D2L, underneath the file you already downloaded, there's going to be another file called uspopulation.txt. That contains the mid-year population for the United States from 1950 to 1990. I want you guys to write a program that reads the file's content into a list. Then the program should display the following data. It should display the average annual change in population during the time period, the year with the greatest increase in population during the time period, and the year with the smallest increase in population during the time period. So again, when you're looking at this list, if we look at this together real quick, go back in here to downloads. We go to chapter 7 here. And we go to US population. We open this. You'll see that it starts at 1950. So you have to understand that that's 1950. So this first number is for 1950, and it's the mid-year population. So it's saying the average annual change during the period. So what that's actually saying is this is the mid-year population, and what you're trying to do is you're going to take this number and subtract it from the previous number, and that's going to give you the average annual change in population during the time period. I'm sorry. You're going to subtract this from this one, and that's going to give you the annual change. Take all those differences and then add them up and then divide by the number of years between 1950 and 1990. That will give you the average annual change. Okay, so again, this is the mid-year population. You're going to have to do some math between the number following it and before it to actually get the actual annual change. Then it says the year with the greatest increase in population during the time period. What that means is, if you look here, there's a difference here. This is an increase. So that means that if this minus this, if this difference is large, the largest, then that's the year where it's the largest right here, is going to be the year with the greatest increase in population during that time period. If this difference here is the smallest amongst all of them, or even negative really, that's the year with the smallest increase in population during the time period. So go ahead and give this one a shot, pause the video, and come back when you're ready to look at it. All right, did you give that a shot yourself? All right, so let's take a look at this together. So if we go to 7-9 here, we'll do the same thing we did before. So we'll do def main, like that. And then we'll say if name equals quote underscore underscore main, set up the file just like normal, like that. What we're going to do is the first thing before we can do anything is just like with the World Series winners, we're going to need to pull this file in. So if we go to uspopulations.txt, we're going to copy that, go back over to PyCharm, click on your actual project. You can either right click and paste, or you can control V. So we'll go ahead and paste in uspopulations.txt just like that. And then we're going to open that. So we're going to do fp equals, just like we did with 10a. So here, fp equals open. We're going to do fp equals open. We're going to do uspopulation.txt, and we're going to read that. All right, so we can take the shortcut again as well, and we can say yearly population equals fp.readlines. If we print that, just like that, if we print that, and we go ahead and run this program, you'll see we have the yearly population. Now, of course, we still have those \ns we'll have to deal with as well. So we'll have to work around that. But other than that, we have the yearly populations as well. So now what we can do is, because we know, and we want to keep track of the years as well, we have 1950 to 1990. We know that, so we can do years equals list of range, and we can start at 1950, and we want to go to and include 1990, so we're going to go to 1991, we're going to increase by 1. So if I print years now as well, and I run that, you'll see we have 1950, 1951, 52, all the way up to 1990, which corresponds with this last population. So the way we can tell and make sure that, and we got to make sure we're right on this, is we'll print, we'll do this before or after each one, we'll do print the len of yearly population, and we'll print the len of years. So these should be the same. Okay, so you'll see we have 41 years and 41 years. So these are what's called parallel lists. Okay, so what this means is that the index for the first item, so 0 here, is related to the index of the other one. So in this case, we do not want to sort this, we don't want to reverse this. If we're going to delete something from one, we need to be careful to delete it from the other as well. All right, so now what we're going to want to do is we're going to want to do the annual changes, just like that. We're going to make this an empty list. Okay, we can actually pull this down here if we want to, organize it whatever way you feel like. And what we're going to do is we're going to get rid of these print statements, because now we see what we're working with, and we're going to iterate through. So we're going to say for year in, or we can actually, since we're working with multiple lists, it's actually better to do year, or we'll say index equals 0. We'll say while index is less than the len of years. Either list is fine because we know they're the same. But we want to use the index because we're going to access both these items. So a for loop isn't really going to help us as much. It doesn't matter which loop you use as long as you have access to the index. But a while loop gives you perfect access to the index right here. So what we can do is say while index is that, we can say the yearly population for, let's say, the index. That's what we're working with. And we can say current year population is equal to that. Now, we're looking for an annual change, which means we want to subtract it from the previous year. So we do not actually want to start our index at 0. We actually want to start it at 1, because we're going to have our current year population, and we're also going to have the previous year population as well. It's going to be the yearly population of the index minus 1. Okay, so we want to make sure that we're not going off bounds of that, and we also don't want to wrap around back around to the other side of the list. So we'll do this. So we're going to start at the second one. So we'll start at this number right here. We'll start at 1951. We're going to subtract 1951 by 1950. So we're going to do, and keep in mind, again, we have that \n, so we're going to have to do .strip on both. Or actually, what makes it easier is we can just do int on both. cast them both to int, so they're both numbers. And that should get rid of the dot strip as well. So then we have that difference, and we can say the annual or the change. We can say annual change dot append current year population minus the previous year population, just like that. So if we go through this, and we could do this each time, increasing the index each time, just like that, then we can print our annual changes. So we run that. You'll see this is the annual change. So between the first 2 years, it was a 2,114 difference, a 2,411 difference, and so on. So now we have all of our differences. So this is the difference for 1952 and so on. Remember, we're not going to have a difference for 1950 because we don't have any data to compare it against to make an annual change. So what we're going to do now is we're going to then say for, at this point, do we really need, let me ask you this, do we really need 1950 on this years list? No. So what we're going to do is we're actually going to say del years sub 0, right? So we're going to delete that years sub 0. So we're going to say delete 1950 to ensure the annual changes and years lists are equivalent. So let me show you what that means. So if I delete that out and I print years and I print years, I say len of years, so the actual length of the years, and then I go down here to annual changes and I print the len of annual changes. If I run that, you'll now see we both have 40. So again, we don't need 1950 once we've calculated the actual changes. We only need 1950 in the list when we're calculating these changes up here, okay? So now we have parallel lists. What we did is these two lists, years and yearly populations, were parallel. We created a new list, annual changes, and then by deleting year 0, we have now made years now not parallel to yearly population anymore, but parallel to annual changes. Okay, so with that being said, now we see this is the change for 1951, 1952, 53, 54, and so on. So what we're going to do now is we're going to find the average annual change. So we're going to find the average annual change. Now, if you remember how we do that, we can do print average annual change. And we can just do, like we did before, we can do dot format, and we can do sum of annual changes divided by the length of annual changes, just like that. So again, we're just adding up all the annual changes that we have, dividing it by the total number of annual changes we've had, so divided by 40. Then we'll print the smallest annual change. All right, so when we get here, here's the question. When we get here, we need to find the year with the greatest and smallest annual change. So we have to find the minimum, the index where it's the minimum. So what we're looking at is we're looking at this part right here. We want to find the minimum. So if we do this, let's leave this guy alone for a second. Let's actually like theory this out. So if we do print annual changes and we do the min of that. So we do min of annual changes. If I run that, it's going to say it's 1881. That's not a year. Remember, it's going to be this one right here. It's 1881. That's the difference in the actual change in population. Okay. With that being said, though, that is a number. That is not a year, right? So we need to find the index for that, right? So we can do annual changes dot index of min, like that. So now we're saying, give me the minimum, which is 1881, and then tell me what indexes that is at. So if I run this now, you'll see it's 16. So if I go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is at the 16th index. Okay, now we have the spot, but again, we don't want the number 16 either. We want the year, in this case 1967, that goes along with that number, correct? Okay, so what we're going to do is instead, with that index now we have, we're going to then do years of that index, just like that. So if I run that now, you'll see it says 1967. So this is a nested method statement here, like we've done before, and we're going to take that, we're going to put that in the dot format here, just like that. So to break this down real quick, again, it's going to make this a little bit easier to see. We have don't mind the yellow right now, but look, we have our annual changes array. We're finding the minimum in that. That gives us 1881. We take the output of that, which is 1881, and pass it to the index function for annual changes, which says, I don't want to know the value, I want to know the index, which gives us 16. Given that 16 now, we can then pass that index 16 to our parallel list, which is years, which matches up with it. And now we can say that year, it'll give us back 1967. Okay, so the best part about this is once you have that logic down, all you need to do now is copy it, paste it, we say largest annual change, and the only thing we change now is we change min to max. Everything else stays the same. So if I run this now, we see we have our smallest annual changes in 1967, and our largest change is in 1955. So here you'll see we have 3185, which does look like it's the largest across the board. And over here, 1967, we have 1881, which does look like the minimum. So again, when you're working with lists, you're gonna have to use the different functions like the sums, lengths, mins, maxes. Here you can see we use the appends. Here we created an empty list. We use the list function here. We use a lot of different of these list methods when working with them. So don't be afraid to actually work around and look at them as well when you're working with them. All right, so let's go ahead and move on from here. So next thing we can do is we can also copy lists, because again, we don't want to have to sit there and work and rewrite lists over and over again. However, when we set a variable equal to a list, they both have a variable reference to the same original list. So what that means is, if I come over here to examples, and I change this, and let's say, let me give it a list. We'll say numbers equals 1, 2, 3, 99, 5. Okay, if I have that list, and then I say num2 equals numbers, then I say numbers, and then we'll say 3, so 0, 1, 2, 3, so it's changed to the 99, equals 100. Then if I print numbers and print num2, what do you think will happen? They're going to be the exact same list. So when working with lists, as I've said before, working with lists, they are not written in memory. A list is a set of locations into different spots in memory where these different objects like strings and numbers that are stored in the list are located at. So when you set another list equal to the original list, what you're doing is you're actually just copying the memory locations of all these values and keeping them in a new list, or I guess the same list, but like you understand that the same memory locations as these spots. So if you want to make a copy of a list, you must copy each list element, because otherwise you're just copying the list element locations. So there's two different methods to do this. You can either create a new list and use a for list to append each of the actual elements, the values of those elements, to the new list, or you can create a new empty list and concatenate the old list, which creates a new empty list. So let me explain. So if I have this numbers, instead of doing this, I can instead do num2 equals an empty list plus numbers, like that. Now if I run that, it's different. Because when I have this empty list and I concatenate the old list, what this is doing is, this is creating an empty list, which is our new list location. And we're going to add all of these values to a new list that we already have. So we're copying over the values now, instead of the actual item locations in memory. All right, the other way to do it is like we said, so we can say num2 equals an empty list, and we can say for item in numbers, and then we can do num2 dot append item, just like that. If we run that, it'll do the exact same thing. It's going to be different. So when you're working with lists, be careful when you're copying them as well. So here's another example. So if I do this is exactly what I showed you before. It will change. However, if I create an empty list first and append them, and then I change num1's list here, it will not change in num2. So here you can see I have num2, you can do plus equals 1. That's another way to concatenate it as well. You saw a second ago I did it this way. Just like that. That is also a way to do it. You can also just do num2. You don't even have to do that. You can do plus equals like this. But here you can see it's not resolving to something. So what you do need to do is you do need to have a list plus something. So you can't really use the plus equals with that unless you already have it as a list, because it doesn't know what it is. All right, so moving on, we can also process lists. So list elements are often used in calculations. So we've already seen this with the mins, the maxes, and so on. So if we wanted to calculate a total for list elements, we can use a loop and an accumulator. We've also talked about how for a total, we can just use the sum for a list as well. To average a list, we can calculate that total and divide by length as well. So here's an example of just the other one way to do it. But again, remember that we also have right here, we also have our sum function, which sums the list as well. Okay, so we also have other functions. So if, for instance, lists can also be passed to functions and returned from functions. So if we have a function called def square values, and we have our numbers, what we can do is this square values here is going to square all the values in the list. So we pass the numbers list right here. And then what we're doing is we're saying I equals 0. And while we go through, we say num of I equals num of I squared times 2, which squares it. We can increment through. We could also have done for item in num, and we could square it that way as well. Okay, and then we return the numbers there. Okay. So we can also write them to a file as well, where we have write lines. So just like how we did before, where we had read lines, we can also write lines as well. However, just keep in mind that if you notice back here, when we talked about the US populations, each of these had their own \n's added to them. Notice that it does not automatically add one when you write lines. So read lines will not automatically take it away, and write lines will not automatically add it for you. So if you do want to add it, you can say, here's your numbers, open it up. This is another way to open up a file, by the way. So you can say with open this text file as file pointer, and then you say for value in numbers, you can write it this way. Now that one of the benefits of using this approach to writing an actual file or opening up a file is once this scope is done, the file is automatically closed for you. But this is a way you can actually go ahead and write files. Notice here we have the \n here. Okay. So now moving on, we also have what's called two-dimensional lists. And all that is a list containing other lists. So for instance, let's imagine, if we come back over to examples, we have something called users, and we have an empty list. We can then say users.append and make a list, and we'll say Bob, his age is like 45, his email is b@gmail, let's put this in quotes, b@gmail.com. We can append that. We can also do users.append, make another user, we'll say Jill, and we'll do she's 32, and we'll do j@gmail.com. So if I print users now, just like that, you'll see, to run this, we now have a list, so you can see the outer brackets, followed by inner brackets with the inner list right here as well. Okay, so what this means for us is when we actually want to do it, we can do users sub 0, and if we do that, it only gives us the first list. So this is where we have to use indexing twice if we just want to get the name. So we have to do 0, 0, and that gives us the 0, 0, which is the actual name. So again, notice here, if I do users, and then I print users, and I get the first person. So that's not Bob, because Bob is 0, Jill is 1, so that's index of 1. That's going to give me just Jill. So it takes away everything but that one item, that one list. Now, if I want to get Jill's email, I have to do 1, and then the email is 0, so it's 0, 1, 2. So I have to do 1, 2, like that. So if I do that, it will give me the email for Jill. Okay? So you need to keep track. So what this is when you're indexing, the first index dereferences or grabs the list element in the actual list there. The next index you have, the 2 here, grabs the item from within that list. So basically you're going down, as you can see here, it sort of goes down in size. So you get one item from the bigger list, then you get one item from the smaller list, just like that. And you can do this with as many layers as you want. So this is what's called a nested list, and you can usually use nested loops to process this. So for an example here, we talked about it. We have Ben and Megan in this case, and we say for row in info, and then we say for val in row. So this is a nested loop, and I say for row in info. That iterates over each internal list. So that's going to give me the first. So row the first time will be Ben with this entire list, Ben32b at Gmail, and then the next iteration will be Megan25m at Gmail. Then if I say for val in row, it allows me to iterate over each of those internal lists. So if you notice here, we have a two-dimensional list. We have a list that includes lists, so that's one list, two lists. If we have a list that includes lists that include lists, then we have a three-dimensional list, and we'll have to have, just like here, we have two loops to deal with a two-dimensional list. We'll have to have three loops to deal with a three-dimensional list. Okay? So if we want to access an element in the 2D list, like I said earlier, you'll have to use multiple subscripts. So in this case, if we want to iterate through each and get the actual user's emails, notice here in each case, they're the same. The email is the third element or has an index of 2, right? 0, 1, 2, 0, 1, 2. If that is 2, then we can say while index is less than this, remember this first index here, right here in info, is dereferencing or grabbing each of the internal lists. So it's going to grab the entire thing from this bracket all the way to the end where it says after B at Gmail. Then the next loop is going to grab this bracket before Megan all the way to the end after the M at gmail.com. So it's grabbing internal lists. It's like an inner package. Then we have those inner packages, and if we do bracket to bracket, it'll give us the emails, just like we see over here. I grab that internal list right here, and then by using the bracket 2, it gives me the email. Okay? All right, so now that we have a pretty good understanding of actual lists, we can move on to what are called tuples. Now, tuples are immutable sequences. Notice here how they use the parentheses. Okay? They're very similar lists, but like I said before, tuples are like working with concrete. Once you set it, once you write this statement right here, we say my tuple equals and put your items in it, you cannot change it. If you want to change it, you'll have to make a brand new tuple. So tuples support operations as lists, so you can do subscripts to retrieve them. So here's an example. If I do, let's see, names equals, and we'll use parentheses this time. We'll say Ben. We'll say Megan. We'll say Sue. We'll say Mark, like that. So those are those names. However, that means I cannot change those names at all, okay, because it's in a tuple. If I were to change this and this to a brackets, now I can change them. By using the parentheses instead of the brackets, you are telling Python that you will never change those values in those parentheses. So if I were to do names sub-0, to run that, it will give me, oh, I actually have to print it, otherwise it won't do anything. Print name sub-0, just like that. It'll give me Ben, which is the first one. I can also use methods such as index, like we talked about before, length, min, and max. I can use slicing operations to get a subsection. So if I wanted to get names 0 to 2, I can get that, and that gives me Ben and Megan's. That's 0 and 1. Remember, it does not include 2 for slicing operations. Notice here, by the way, it also brings it back as a tuple, a new tuple. That does not mean that, like, for instance, if I come over here and I say new names equals these names, and then I say new names of 0 equals Bob, like that. I cannot do that because when you slice a tuple, it returns a tuple. So you need to be careful about that. You can also use the in, plus, and star operators as well. However, just like I said before, tuples do not support modifications. So you cannot append, remove, insert, reverse, or sort them because all of those change the order and the order of the items as well as the values of those items in it. So one of the advantages of using tuples over lists is that that tuples are processed faster than lists. The reason being is because Python does not have to think about the fact that it might have to change them. So it's easier to store them and streamlines the storage process. Tuples are also safer as they're static, so you don't have to worry about if something doesn't need to change. If you have a list of something that shouldn't change, then you don't have to worry about them being changed, because obviously you can't. And then some Python operations require the use of tuples. So when you're using certain functions, they might require a tuple instead of a list, and therefore you'll have to use a tuple at that point. However, even though I said that tuples you can't actually change, you can convert tuples to lists and lists to, or tuples to lists. So you can go back and forth between them. Just like we said before, we have a list which takes in something and a tuple that takes something. So if I did want to change something, I could say new names is names like this, and I could say cast that to a list like that. And then I could say new names, and I could say sub1 equals Robert, like that. And then I could say new names equals tuple, not turtle, tuple, of new names. So that's one way you can change a tuple, but you have to go through the process. So now if I print new names, and I run that, you'll see it says Ben and Robert now instead of Ben and Megan. So the reason why this is important is because you have to go through this extra step, the conversion, the change you want, and then converting it back if you do want to change a tuple. Otherwise, it will not be able to be changed. And this is actually true because the original tuple that you have right here isn't actually there anymore. You're converting it to a list, you're changing a list, and then you're making a brand new tuple again with this cast right here as well. All right, so let's see how you understand this. So if I asked you this question here, how many rows and columns does the following 2D list have? Look at this here. We have the 2D list, so we have 2 dimensions. So you know that we have 1, 2, 3, 4. So no, again, it's going to have 4 rows. The rows are the count of the items in it, the list items that are in it. So it's 1, 2, 3, 4. And the columns are going to be the number of items in each internal list. So it's 1, 2, 1, 2, 1, 2, 1, 2. Okay? How would we create a 2D list of zeros with 3 rows and 4 columns? So let's go ahead and get started with that. We'll say zeros equals empty brackets. Then we say 4 row in range of 3. So we make those different rows. We're going to append, because we want 4 columns and 3 rows. So this is the column right here. Remember 1, 2, 3, 4. That's 4 columns and 3 rows. That's the range of 3. We're going to do 0, 1, 2. So we're going to append 3 extra lists of 4 zeros to the zeros array, or the zeros list. So now if we ask the question, what is the primary difference between lists and tuples? Just know that lists are mutable and tuples are immutable. And give 2 reasons why a tuple exists. Tuples are faster to process and are safer since they're static. And you also may need to use them for certain Python functions as well. All right, so let's try this. So this one right here says the local driver's license office has asked you to create an application that grades the written portion of the driver's license exam. So what we're trying to do is we're trying to make a program that grades the written portion of the driver's license exam. The exam has 20 multiple choice questions with the following answers. Here's your list of answers. Write a program that stores these answers in a tuple. Following this, the program should read a student's answers from a text file and store the answers in a list. The program should then compare the answers and display whether the student passed or failed the exam. A student must correctly answer 15 out of the 25 to pass the exam. So let's go over to 7-7 here that we've made earlier. We'll do def name. Then we'll do if name equals quote underscore main. Like that. Now, the first step is we were already given the answer key. So let's go ahead and copy this. If you're at home, take a moment, pause the video, and record this, write this down, and make it in your own list. And we're going to store these, and it says the program should read, this should be stored in a tuple. So we're going to come in here, and we're going to say answers equals this. Now, it's going to be a tuple, and each one of these will have to be in quotes. So you can do that, and if you hit shift and quote, when you highlight something, you can put a forward first and back end quote at the same time. Makes it a little bit easier. We can go through this. Make sure we quote everything here. Otherwise, it'll throw an error because it doesn't know what a non-quoted string is. Keep going through. All right, so now we have our answers, and they're in a tuple, so they should not be able to be changed without more effort. Basically, it shouldn't be able to be changed. All right, so now what we need to do is we need to have a file that reads a student's answers from a text file and stores them in a list. So first things first, we'll need to make we'll do a new file, just like this. We're going to name it student, we'll do student answers.txt. All right, so we're going to read lines. So what we're going to do is we're going to do something like just like put a whole bunch of answers in. Noting here, again, there are 20 questions, so let's make 20 answers. Do A, B, C, 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 D, A, B, C, D, A, D, C, C, A, C, C. So that gives us 20 answers. Okay, so we'll go ahead and save that. Now if we go back to where we were, we can read that in. So we'll say FP equals open student answers. We'll read that. And then just like before, we're going to do FP, we're going to say student answers equals fp.readLines because it's the easiest thing to do. And then here it says it should compare the answers and display whether they passed or failed. So we'll have a counter here. So we'll say correct equals 0. And we'll say for answer or for, let's say, yeah, for answer in student answers. So we'll say for answer in student answers. We'll then say if answer dot strip, because remember the student answers being read from a file, we'll have that \n is equal to, oh, see, here's a problem here. We don't have the index that we need for this right here. So there's two fixes. We can either use a while loop, or we can say for index in, that's another way to do it, say for index in len of student answers, that's the length, and we can do a range function around that. So we can do range of len, just like that. And that will give us an index. So we can say if answer, we got to put an index now, so we'll do index dot strip equals answers of index. We can change this name to make it simpler, so we'll say correct answers. We'll change that here. And we'll say for student answers. And we'll say if student answer of index.strip is equal to the correct index, then we'll say correct plus equals 1. At the end here, we'll print correct, and we'll see how many we got right. Let's go ahead and run this. We got 6 right. That's not very good. But what we can do here is we can look, we say 1, 2, 3, 4, 5, 6, 7. 7 were A's. So if we wanted to, we can go back and actually fix this, but let's go ahead and actually add this last part. So we say if correct is greater than, then you get 15 out of the 20. So we'll say greater than 15. Then we're going to print congrats, you passed. We'll say else, we'll print you failed, like that. All right, so either way they're going to pass or fail. We can print the correct total up here as well, just for visual purposes. And what we can do is we can come back in here. Let's change the first one, this one to C. We'll change this one to A. We'll change this one to A. So now we should have 4 more that are right. So if I run this again, we now have 9. So we change those few. So now we say you failed. Let's keep going. We do D, B, C, A. So we'll do D, B, C, A, like that. Okay, we're getting closer. And then we'll do, at the end here, we'll do B, B, D, A. So we'll do B, B, D, A. Right? And we passed. So we matched up enough of our answers here to the actual tuple that we have in memory, stored in memory, that we now have passed, because we now have 16 correct. Okay, so now you can see how we can actually use a tuple. In this case, we can store this because this answer key should not change. And we can store that answer key in memory and compare it, what we read from a file, into memory, and then compare it, and then go ahead and actually give them a pass or fail grade. All right, so at this point, what I want you guys to do is I want you to try this. So a low shoe magic square is a grid with 3 rows and 3 columns. The grid only contains number 1 through 9 exactly, and the number of each row, column, and diagonal all add up to 15. I want you guys to write a function that accepts that two-dimensional list as an argument and determines if it's a low shoe magic square. So here's an example here. This right here is an example of one that works. So 4, 9, 2, 3, 5, 7, 8, 1, 6. So if this is correct, if this is put in as your two-dimensional array, or two-dimensional list, it should come back as correct. So what you'll need to do is you'll have to take each row, add it up, make sure it's equal to 15, add this up, make sure it's equal to 15, add this up, make sure it's equal to 15. Then you'll have to add up each column and then each diagonal as well. So you have to do 1, 2, 3, 4, 5, 6, 7, 8 computations. All right, so go ahead and pause this. Think about it. I know it might be a little bit difficult, but think about it. Give it a shot. And then when you're ready, come back and we'll talk about it. All right, so did you give this a shot on your own? All right, I know it's a little bit difficult, but let's go ahead and look at this. So we'll go to 711 here. And what we'll need to do is we'll have to say def main. Then we'll say if name equals main, just like that. And what we're going to do is the first thing is we need to get a two-dimensional list from the user. So what we're going to have is we're going to say user input. So we'll say square equals this. And then we'll say for I in range of 3, because each row is going to have 3, and then for j in range of 3, and each column is going to have 3. We're going to say, let's say we're going to make a temporary list here, so we'll say row equals this, and then we're going to say row.append, and we'll take an input here, and we'll say enter the, now, how do we know which list and row number we're on? Okay, so we can say is we can enter the blah row, the I row, and j column number. Okay, so we'll do dot format here. We'll say I, comma, j, just like that. Now again, we'll need to have some kind of input validation. So we'll say while true, and then we'll say try, and then we'll have except here, and we'll say print invalid number. We'll put this around in an int function here as well. Okay, and if that does work, we'll then do break, just like that. And now we have our input validation function. So if we run this real quick, we'll see what this looks like. So let's see, run this. So it's 0, 0, so it's the first item. So let's go ahead and put in, we have 4, the 0th row, first column, 9, 2. Now note, we're on the first row now. Okay, here's the problem. We've appended that row, but we never actually appended the row to the actual square. So we'll do square.append row, like that. Now that we've done that, we can go back and restart this. So let's go ahead and kill it. Okay, and we'll just go ahead and rerun this. And we'll just stop and rerun. Okay, so we'll do 492. So 492 357 357, and then we'll do 816. So 816. All right, so that gives us that, but we didn't print it out. So we'll do print square, and this will tell us if we got it right. So we'll do 492 492 357, and then we have 816. So we'll do 816. All right, so you see 492 357 816. Now if you take these and stack them on top of each other, then we now see we have our square. So now we need to be able to check the square. So we'll say check the low shoe magic square. So the first thing we need to do is we need to check rows. And here's the thing. If we ever at any point find out that it is not a magic square, we can stop. We don't need to check every last thing. So what we'll do is we'll say for row in square. Just like that. We need to check to see if it adds up to 15, right, for each row. So for each row, we'll say square, or sorry, we already have our row because we're doing a for loop. So we have row. Actually, let's just sum the rows. So we'll do total equals sum row, just like that. Now we've summed the row. We say if total is not equal to 15, if it's not the same, we're going to print not a low shoe magic square. And then we can just go ahead and return because the program is done. We don't need to go any further. We can just stop the program. Okay, so let's try that real quick. So let's run this again. So we do 4, 9, 2, 3, 5, 7, 8, 1, 6. Okay, note how it did not error because it went through each row. So it added 4, 9, and 2 together, which is 15, 3, 5, and 7 together, which is 15, and 8, 1, 6 together, and it's 15. So we've checked the rows. Now we need to check the columns. So to do that, we're going to have to iterate through both. So let's take the same logic here. So we'll say for row in square, but then we also have to say for column in row. Does that make sense? So what we're doing is now each row is giving us back, if I print this here again, so if you guys remember what we looked like, it was giving us 492. So I say for row in square. So I'm saying give me that row and then give me that column, okay? So there's an actually easier way to do it when you're working with columns because now we're trying to go up and down like this, okay? That's a slight problem here, okay? So what we're going to do instead is we're going to say, we're going to use indexes now. We're going to check columns, and we're going to use indexes. So we're going to say I equals 0, j equals 0. You can also say row equals 0, say col equals 0 as well. Then we're going to say while row is less than the len. Now here's the thing, we need to make sure we get the length of a row. So we do len of square sub 0, like that. So it gives us the length of a single row in the square. Then we also say while col is less than the len of a square. Okay, now here's the problem here. So do we have any way actually of figuring out how large they are? So we'll say row size equals 3 and col size equals 3 because we know it's a 3 by 3. And we can just say while row is less than row size, we can say while col is less than col size, just like that. Now we can iterate over this. So what we're going to do is for each column, we want to do that. So we actually might want to invert this. So we'll say while col is less than col size, and then we'll have the row size on one side. So we're doing it for each column. So we have our column, and then we have our total. Just like that, we'll set that to 0. So what we're going to do is we're going to say square. So let's say total plus equals square. Now, we know which column we want, but which row do we want? We want the row that we're currently on and the column that we're on. But we're going to iterate row each time. Then we're going to iterate column each time here. Just like that. So what this is going to do is we now have our row, which is going to be the first row, the second row, the third row, and our column. Now this column is not going to change. This loop's going to go through. It's going to give us, so the first time this row one goes around, it's going to give us 0. Let's say the first row and column is going to be 0, 0. So it's going to give us this 4. The next time it's going to be 1, 0. So it's going to give us this one. The next time it's going to give us 2, 0. So it's going to give us 8. So it's going to give us 4, 3, and 8. So if we go through that, we can then, if the total, we can just copy this up here as well. If total is not equal to 15, just like that, we can then print not a low shoe magic square and return. So let's run this again. So if I do 492, so 492, 3, 5, 7, 8, 1, 6. Notice how, so we have a small calculation error. So let's look at this. Let's go ahead and look at this, what we have. So if we do print here, so when we get to this stuff, we're going to have lots of small intricate problems that go along with this stuff. So you have to learn how to debug this stuff. So we do row, do column like that. Now let's see what we actually have. We have 4, 9, 2, 3, 5, 7, 8, 1, 6. So you'll see it says 4, 3, 8. So 4, 3, 8. Is that what we wanted? Yes, 4, 3, 8. And it says, so 4 plus 8 plus 3. Is that not equal? That should be equal to 15. So we have 8, 9, 10, 11. Yep, so it's equal to 15. So why did that not work? So here, if you notice, we didn't put our total check where we're supposed to be at. We put it down here. So that total was continually adding and adding and adding, right? So, or was it? Let's look at that. Let's do this. So the easiest way to do that is just print debug. So let's print total here. So we'll do 4, 9, 2. We'll then do 3, 5, 7, 8, 1, 6. So the total is 15 right there. So why does it say if total is not equal to 15, then we print that? So let's ask that question. Why do you think that even though I have total here, and then that's there, why did I not do that? Do you see that? So the issue is that I set my row and column to 0 and 0 here. The problem is I never reset my column, my row. So I actually need to bring this down in here. So now every time this row goes back around, it resets row to 0, and the column is set to 0 at the beginning. So now if I run it, we now have 4, 3, 8, 3, 5, 7, 8, 1, 6. And now we have no issue. Oop, actually we do. 3, so we have 4, 3, 8, 3, 5. Did I put something in wrong actually? 4, 3, 8, 3, 5, 7. 8, 1, 6. Oh, see, I put it in wrong. I did 4, 3, 8. It's supposed to be 4, 9, 2. If I run that again, I do 4, 9, 2, 3, 5, 7, 8, 1, 6. And now we have no issue. You see this part right here, it adds all those up. 15 adds all those up. 15 adds all those up. 15. So when you're testing this, you also have to be careful not that you don't accidentally cause an issue with a bug. All right, so once we have that done, we can get rid of the print statements because we don't need those anymore, because we now know that it works. Keep the print statements for the actual like printing out not low shoe magic square, but keep that's okay for the rest of it. All right, so now comes the fun part. So the fun part is we need to check both diagonals. We only have to check 2. We only have to go this way because both this way and backwards is the same. We have to go this way as well. So in this case, would it make a lot of sense to actually check with a loop? We can, and we will, but you can also hard code this as well. So what we'll do is we'll say row equals 0 here, and col equals 0 here. So we're going to check the diagonals, just like that. All right, so how will we check the diagonals? So in this case, we have 0, 0, then we have 1, 1, then we have 2, 2, right? So what we're going to do is we're going to say while row is less than row size, and we're going to have a total up here, just like that. We'll then say, square, so we'll do total plus equals square of row of col, just like that. And then we're going to increment both row and we're going to increment col, just like that. Now, at the end of this, we're going to go ahead and print total, just like that. If we run that, we now do, so we'll do 4, make sure you get this right, 9, 2, 9, 2, 3, 5, 7, 8, 1, 6. All right, so you see this is 15. Because what we're doing is we're starting at 0, 0, which is here. Then we increment row and column. Then we increment row and column again. So just like that. So now what we'll need to do, this is a little bit iffy here, is now, that's the easy way, is going that way. This way, we're going to have to go backwards, and instead of being the same, they're going to be the exact opposites. So what we're going to have is we do the exact same logic here. We'll do it down here. We'll check the forward diagonal, and then we're going to check the back diagonal, or the backwards diagonal. We'll check the backwards diagonal. Just like that. Okay, so in this case, we're going to have this actually set to the row size minus 1. Okay, so we're going to have them flipped. And each time, row is actually going to decrement by 1, and column is going to increment by 1. The reason we're doing this is because here you have the row is, or you can either do it either way. Technically, I'm doing it this way. The row in this case is going to start here, and the column is going to be 0. Then they're going to flip. So this starts at 2, so 0, 1, 2, and this starts at 0. So if I subtract 1 from 2 from the row, it's going to go up 1. And if I add 1 to the column, it's going to go over 1. So you have to go backwards on that as well. So what happens is, and let's not forget to put this down where we have this print here. And what happens is, after we do that, we can print the total here, the new total. And if we do this, we do it correctly, so we do 4, 9, 2, 3, 5, 7, 8, 1, 6. 1, there we go, 6. Oop, I might have missed one here, hold on. 4, 9, 2. Yep. 3, 5, 7, 8, 1, 6. Okay, so this is where we have run into an issue here. So we're saying while row is greater than row size, but we're decrementing row. So technically speaking, this will always go out of bounds. So what we actually need to do is we're going to say while col is less than col size, because that's the one that's incrementing, and that'll fix our issue. So we have 4, 9, 2, 3, 5, 7, 8, 1, 6. Okay, so once we've gotten to this point, we've checked every aspect of that low shoe magic square. So at the very end, you can then just print, this is a low shoe magic square. And put a little exclamation points there for them to say congrats. So now if we do it, we do 4, 9, 2, 3, 5, 7, 8, 1, 6. So it says it's a low shoe magic square. But if you put in any other kind of square, so we do 4, let's say 9, 2. Actually, let's flip 8 and 2 here. So we'll do 4, 9, 8, 3, 5, 7, and then we'll do 2, 1, 6. Okay, that's not a low shoe magic square, because again, if we flip these two, yeah, that works for this diagonal, it works for this row and column, but it does not work for this column right here, because now that's not equal to 15, or this row, which is not equal to 15. So a low shoe magic square only works if everything's equal to 15. So with this being said, now you can see that when you're doing this, you're going to have to debug it. You're going to have to work through these problems piece by piece and break it down. Notice here, we check the rows, then we check the columns, then we check the forward diagonal, and then we check the backwards diagonal. You work through that, breaking it down piece by piece, especially with these larger problems, to make sure that you can fix and solve every problem as you go. All right, so with this being said, have fun with this program, try some different squares out, see if you can't come up with your own low shoe magic square. There's not only one, just like with Sudoku, there's not only one type of answer for that either. So go ahead and try that out, and then we'll continue on. All right, so now that we've worked with lists, the next thing we're going to do is we're going to actually plot data with matplotlib. So as you saw a second ago, we had 2D data. 2D data is the same thing as working with plotting data, okay? So what we can do in Python is we can actually use what's called matplotlib to plot math data. So what you need to do first is you'll have to put this command in first. So you'll have to do python3-m pip install matplotlib. So if you do that, if I come into my terminal here, you have your command prompt. You can do Python 3, and you'll see your Python version pop up. Hit exit with the parentheses after it to get out of that. And if you do Python 3-m pip install, and you do matplotlib like that, it'll install it for you. Okay, so it'll go through it all, install the actual package for you, goes through everything for you. You don't have to worry about nothing. Python makes this very easy. Okay, so once you're done, you now have that package. All right, so once you have that package, you can close your terminal. Here's a link to the actual documentation for it if you want to learn more about it. But to use it, we're going to use import matplotlib.pyplot as PLT. Okay, this as part is an alias. So what that allows us to do is instead of having to type in matplotlib.pyplot every time, we can just type in PLT that you'll see in a second. All right, so once we have that, what we can do is we can actually use that plotting library. So the first thing here is you can see right here, we can actually plot a line graph. So we have import matplotlib.pyplot as PLT. We create a list of x coordinates and y coordinates, and then we can plot them. So let's go ahead and try that. So let's go back to the examples here. And we'll do import matplotlib.pyplot as PLT. Okay. Note here it says it's not. We'll just go ahead and hit this just to make sure. Okay. Install package. So down here it says it's installing it. So if you installed it one way, it might work. It also might not show it. Just give it a second. Okay, just give it a second. It's doing its thing. Okay. All right. So once you have that, now you see it lights up. Now you have matplotlib. So we'll do our def main again, just like we do every time. We'll say if name equals quote underscore main. Do main just like that. And we'll do, go ahead and do this. So we'll do x coords for x coordinates is equal to 0, 1, 2, 3, 4. So we'll do 0, 1, 2, 3, 4. And we'll say our y coordinates. We'll say something crazy this time. We'll say 100, 35, 45, 90, and then we'll do 20, just like that. So now if we do PLT, because we're using an alias now, so we don't have to put this entire name, we do PLT.plot x coords, comma y coords, like that. It'll build a plot for us. To see that plot, we do PLT.show. So if I run this now, you'll see it creates a graph for us right here. So now you can see we have 0 and 100. At the 1 point down here, we have 35. 2, we have 45, and so on. This is how you can build a plot in Python. After that, you can actually save it. You see a little save icon right here. You can actually save the figure to a PDF and put it in a paper or a document or a presentation or whatever you want to do. All right, so that's how you can make the plots in Python. We have line graphs. We can also change the actual plot as well by using plt.xlim. So you can change the limits on the actual plot, the axes. You can also set the ticks as well. So if we wanted to change them to years, we could do that as well. And we can sort of see that right here. So if we take this code right here, it might cause a few issues, but we'll try to just keep this simple. We'll copy this, put it back in here. It might cause an issue, might have to fix a couple things. Yep, figured as much, but that's okay. So what we'll do is we'll take that, put sales by year, just clean this up. You guys can type it on your own if you want. Sometimes things don't import nicely into Python. Get rid of that. Fix that. Fix that. Fix that. Okay. Then we have our X ticks right here. We'll have to, so those guys fixed fine. And then we have to do that. That didn't enter correctly there. There we go. So we have our Y ticks here. We have 0 million. That's not entering correctly. That's okay. Gotta keep bringing this stuff back up. Okay, and this last tick is just different as well. There we go. All right, so if we do this, it's going to change. So what this is doing is we have our coordinates like before, sales by year. We have our years, our sales, and it's going to change them. So instead of saying 0, 1, 2, 3, 4, it's going to give us these different years. And then we have our y ticks, which is going to be 0, 1, 2, 3, 4, and 5 million instead. If I run this now, you'll see we have a much nicer looking graph. So instead of having 0, 1, 2, 3, 4 on the bottom, we have 2016, 2017, 2018, 2019, 20. You see we have years and sales right here. We have our title, which is sales by year at the top here. And we have, instead of 0, 1, 2, 3, 4, 5, we now have 0 million, 1 million, 2 million, 3 million, 4 million, 5 million on this axis as well. So at this point, you could actually save this graph and use it in some kind of presentation if you needed to. All right, so you can customize the line graphs that way. Here's another example of that same graph, breaking it down. And we can also make bar charts and pie charts as well. So again, there's a full gallery about how to do these. So with this, it's going to be more of trial and error on your part to try different things that you want to do as well. All right, so what I want you guys to do is try this on your own and create a text file that contains your expenses for last month in the following categories. We have rent, gas, food, clothing, car payments, and miscellaneous. And I want you to write a program that reads the data from the file and uses matplotlib to plot a pie chart showing how you spend your money. So go ahead and try this and unpause it when you're ready to see how it's done. All right, so do you give this a shot on your own? All right, so let's go over this. So we need to make a text file just like before. So we'll go up here and do new file. We'll say expenses.txt. So let's just go in order. So we have rent. So let's say we spend $1,400 on rent each month. The next one, let's say gas, we spend $180. Let's say on food, we spend $1,000. Let's say on clothing, we spend $300. We like shopping. On car payment, let's say we spend $500. And then on miscellaneous, let's say we spend $600 because we have a lot of different expenses. All right, so what we can do now is underneath this in 714 here, we can go ahead and do the exact same thing we did in the example. So we'll do def main import this. Actually, we'll just take the entire thing here and paste it in here. You'll learn that in programming, you will not write your own code. Like repeatedly writing code each time is not really fruitful. All right, so what we're going to do is we're going to open our expenses. So we'll do fp equals open. We'll do expenses.txt, and we're going to read that. Just like that. And we're going to read that into a expenses list. So we'll do expenses equals fp.read lines, like that. Now what we're going to do is we're going to do for item in expenses, so we can get rid of those backslash n's. We're going to do item equals item.strip. That just goes through and gets rid of those backslash n's for us. Okay, so now that we have read the data in, make sure you close your file as well, so we'll do fp.close. And now that we have our data, what we need to do is we can plot it. And in this case, it says to use a pie chart. So what we're going to do is just like we did back here, we have the matplotlib index. So we're going to copy that, go to that URL, and we're going to look at how to use a pie chart. So we go here, you'll see we have all these different examples. So we're going to scroll down until we actually see pie chart. Keep going. You can also look over here, and you'll see pie and polar chart. So we'll click that. We'll just do a basic pie chart. So the cool part about this is you'll see that at this point, they give you code that you can use to make these charts. So you can take this code right here, copy that into your program right there, and you can change this. So we already know that the labels are going to be, if we go to the next slide, like rent, gas, food, clothing, car payment, NISC. So we'll do rent, gas, food, car payment. So rent, gas, food, I missed clothing here, so we'll do clothing here. So we'll do that, and we'll do clothing here, like that. And then we have MISC after that. So we'll do MICS, just like that. All right, so then we have sizes. Okay, so the sizes are going to be based off the total. So what we're going to do is we're going to do expenses. Make sure we actually up here we convert these to floats, like that. And then we're going to do expenses sub 0, the first item, divided by expenses, and we're going to do the sum of expenses here, just like that. So that's going to give us the actual size for that first one. And we're going to repeat this process. So we're going to do it once, twice, 3 times, 4 times. And remember, we had to change the zeros there. So it's going to be expenses sub 0, 1, 2, 3. Keep going there. 4. So we have 1, 2, 3, 4, 5, 6. So we need to go one more. And we're going to do 5 here, just like that. So that'll give us our different sizes. So if we run this now, with all the only thing we changed was that. Give it a second. So now it says unsupported operand type for plus. This is int and string. Okay, so what that means is that something's going on here with this as well. So what we need to do is we're going to go ahead and print our expenses here. Let's see what that looks like. Okay, so it still has this \ns, this little pesky \ns here. So what we're going to do is we're going to say for item in expenses like that, but that didn't really work. So what we're going to do instead is we're going to do so we're going to say for index in range of len of expenses like that. Then we're going to say expenses of index is going to be equal to float of expenses of index, like that. So we'll get rid of this because that just didn't work. And sometimes that just happens in Python because there's reasons. So for instance, when you're working on a for loop, sometimes it doesn't want you to change the actual items in it. If we run that now, you'll see that it actually did work. So we have these numbers now. But now it says explode must be of length x. So right here it says explode must only explode the second slice. So that was causing an issue. So what we can do is we can just get rid of explode here. See if that works any better here. Just make sure we don't have it. And take that option out if it doesn't work. Try it again. And now we have our pie chart. So we'll just go ahead and deny that. So we can see right here that 32% of our expenses are rent, 15% is MISC, 12% is car payment, 7% is clothes, 25% is food, and 4.5% is gas. So this is how you can easily see the budget you want, or what your actual expenses are for the month, and you can go forward from there. So that's how you can actually make a pie chart in Python. All right. So in this actual chapter, we've covered what lists are, including the repetition and concatenation operators, indexing, techniques for processing lists, slicing and copying lists, list methods and built-in functions for lists, two-dimensional lists, tuples, including their immutability, the differences and advantages over lists, and how to plot charts and graph charts with the matplotlib package. So at this point, we have a pretty good understanding of lists. There's more to lists. There's always going to be more to programming. You'll have to learn that stuff on your own. But we covered the base foundations of lists in this class and in this lecture today. Thank you, and I'll see you in the next lecture.